So today we are doing 7.5, which is talking about solving equations containing rational expressions. So that being said, let's get into it. So part one, solving equations containing rational expressions. That's literally like all we're doing in this lecture. Objective, title of the notes, we're solving equations containing rational expressions in case you didn't hear. So part one, recall, equation versus expression. So this is something that you might not have given a lot of thought about, but once I say it, you're gonna be like, oh. An equation contains an equal sign and an expression does not. So what defines an equation is that equal sign. So solving equations containing rational expressions. In general, what we do to solve equations containing rational expressions is first clear the equation of fractions by multiplying both sides of the equation by the LCD of all rational expressions, then solve as usual. So 7.2 part one is coming back to haunt us with finding LCDs. So hopefully that part made sense to you. If not, come see me in tutorial. But let's do an example. So we have 4x over 5 plus 3 halves equals 3x over 10. So first thing we want to do is find what is the LCD. So we're going to look at our denominators. So we have 5, 2, and 10. The LCD for 5, 2, and 10 is going to be 10. Right? If we had a bunch of fractions, which is actually what we have, that were over 5, 2, and 10, our common denominator would be 10. Okay, and so what we're going to do is now we're going to multiply our whole equation by 10. Okay, so that means that, and you can either write this as separately multiply by 10 on this side and separately on this side, or whole thing, but you do have to remember you're multiplying both sides, so both sides of the equal sign. So this is going to give me 10 times 4x over 5 plus 10 times 3 over 2 equals 3x times 10 over 10. And now we can go ahead and simplify that a little bit, right? Because 10 over 5 is going to be 2, 10 over 2 is going to be 5, 10 over 10 is going to cancel. So now I have 2 times 4x, which is 8x, plus 5 times 3, which is 8, so I have 8x plus 8, or excuse me, 5 times 3 is 15. I don't know where I got 8 from right there. 5 times 3 is 15, is equal to 3x, and now I can just solve accordingly, right? So I'm going to subtract 3x, so I'm going to get, or actually, yeah, I'm going to subtract 3x, so I get 5x, I'm going to subtract 15 from this side, equals negative 15, divide by 5, x is equal to negative 3. Okay, so as soon as we get rid of our fractions by multiplying by the least common denominator, then we're just doing regular old algebra that we know how to do. Quick thing, recall, a rational expression is undefined for the values of the variable that make the denominator 0, okay? So if a proposed solution makes the denominator 0, then it's not actually a solution because then the rational expression would be undefined, okay? So read that statement again. I said that kind of quickly, but this is important. If you get a solution and you plug it back in and it makes your denominator 0, it is not a solution. Okay, so here are some more specific steps for solving an equation containing rational expressions. Multiply both sides of the equation by the LCD of all rational expressions, simplify both sides of the equation, and then check the solution in the original equation. So without further ado, let's do another example. So we have x plus, I'm going to scroll, give myself some more space to write. Okay, so we have x plus 6 over x minus 2 equals 2 times x plus 2 over x minus 2. Step 1 is to multiply by the LCD of the rational expressions. And in this case, we're lucky enough that the LCD is going to be x minus 2 because our denominator is the same. So when you have a denominator that's the same, you're just going to multiply by what that denominator is. So in this case, your denominator is x minus 2. Okay, so I'm going to multiply by that to both sides of my equal sign. So I'm going to have x minus 2 times x plus 6 over x minus 2 equals 2 times x plus 2 times x minus 2 over, I wrote that kind of weirdly. All right. 2 times x plus 2 over x minus 2 times x minus 2. Okay, and so now something convenient is going to happen for us, and that is that these factors, x minus 2, are going to cancel, right? Because we have it multiplied in our numerator and in our denominator. So we can cancel that whole factor, x minus 2, which conveniently gets it out of the denominator. And then we are left with x plus 6 equals 2 times x plus 2. So we know that x plus 6 equals 2x plus 4. And then we know that we can add an x, 6 equals 3x plus 4. We will subtract the 4. So we are going to minus 4. Oh, I did that wrong. We are going to subtract an x. So we are going to get, this is why you should always write out your work. Look at that silly mistake. Math teacher, silly mistake. Write out your work. Minus x, 2x. So we're going to have 6 is equal to 2x minus x, which is x plus 4. Now we're going to subtract 4. 6 minus 4 is 2, so we're going to get 2 is equal to x. However, when we plug in 2 to our denominator, x equals 2, x minus 2 becomes 2 minus 2. So the solution we got makes our denominator equal to 0. So is x equal to a solution to this problem? Hopefully you said no, because the answer is no. And this solution and this problem would have no solution. Okay, so the equation has no solution. You have to be careful. You always have to double check that your answer plugged back in does not make your denominator 0. All right, let's do another one. We have 2x over 2x minus 1 plus 1 over x equals 1 over 2x minus 1. Okay, so our LCD is going to be the product of all of our unique factors. So our unique factors include 2x minus 1 and x. So our LCD is going to be x times 2x minus 1. So we are going to multiply our whole equation by x times 2x minus 1. So each distribute that out. So we're going to have x times 2x minus 1 times 2x over 2x minus 1 plus x times 2x minus 1 times 1 over x equals x times 2x minus 1 times 1 over 2x minus 1. Okay, and now conveniently, we're going to have some cancel action. 2x minus 1 will cancel for us. X will cancel for us. 2x minus 1 will cancel for us. And then we get x times 2x plus 2x minus 1 equals x. Okay, and so now we're going to have 2x squared plus 2x minus 1 equals x. We're going to subtract that x to the other side. 2x squared plus 2x minus x minus 1 equals 0. 2x squared plus x minus 1 equals 0. And if you're seeing this, then hopefully the alarm is going off in your head that we need to solve this by factoring, right? The x method, we have 2x, we have a trinomial, we're solving for x, so equal to 0, factor and solve. So on the top, we're going to have negative 2. In the bottom, we're going to have 1. 2 times 1 will give me 2, but it needs to be negative 2 and positive 1, so it's going to be negative 1. And then I need to divide by my coefficient, which is 2. 2 over 2 is 1. So my solution to this problem is going to be x plus 1 times 2x minus 1 equals 0. And then when we have two things equal to each other, equal to 0, we can set them each equal to 0. So I'm going to draw an arrow over here. x plus 1 equals 0, x equals -1, 2x minus 1 equals 0, 2x equals 1, x equals 1/2. I got x equals -1 and 1/2, but I need to check those. X equals -1 will not make my denominator 0, so this guy's a good solution. X equals 1/2, if I plug in 2 times 1/2 minus 1, I get 1 minus 1, which is equal to 0. So 1/2 does not actually work as a solution. So my actual solution is -1. Again, always check your answers, and you're going to get more than one answer sometimes. So you need to check your answer. And you also need to remember how to solve equations that contain polynomials. Okay, so that was a review of chapter 6. And I know I keep harping on this, but guys, everything is building on itself. So again, if you need any help at all, come see me, please. And then our last problem, we have, what do we have? We have 2x over x minus 3 plus 6 minus 2x over x squared minus 9 equals x over x plus 3. We know that to find a common denominator, we need to factor. So I'm going to go ahead and factor x squared minus 9, which I immediately recognize as x plus 3, x minus 3 for difference of squares. And then my LCD, therefore, to include each unique factor will be x plus 3 times x minus 3. So whole thing multiplied by x plus 3, x minus 3, choo. So x plus 3, x minus 3 times 2x over x minus 3 plus x plus 3, x minus 3. I hope you have a lot of paper for these type of problems. Over 6 minus 2x over x plus 3, x minus 3 equals x plus 3, x minus 3 times x over x plus 3. Okay, and now conveniently, x minus 3 goes away. X plus 3, x minus 3, x plus 3. And now we're going to be left with x plus 3 times 2x plus 6 minus 2x equals x minus 3 times x. Okay, and now it's just down to some good nitty-gritty algebra. So 2x times x plus 3 is going to be 2x squared plus 6x plus 6 minus 2x equals x squared minus 3x. Okay, so now I'm going to go ahead and subtract x squared and add 3x to get one side equal to 0. So I'm going to have 2x squared minus x squared, which is going to go ahead and give me 2x x squared plus 9x, but then I have this minus 2x, so I'm going to have plus 7x. And then plus 6 is equal to 0. I'm going to need to, again, use the x method to solve. In the top, I'm going to have 6. In the bottom, I'm going to have 7. 1 times 6. And so my factors will be x plus 1 times x plus 6 equals 0. So x plus 1 equals 0. X equals -1. X plus 6 equals 0. X equals -6. And then if I plug in either of those into the denominator, neither of them will make my denominator 0, so they are therefore both solutions. Okay, so these problems seem intimidating, but if you can figure out the LCD, you will get rid of all the fractions, this step right here, and then you will just be stuck with algebra, okay? And I know we could all use a little bit of algebra practice, clearly. I even made mistakes in this video. But take it slow, show all your work, be neat and organized about it, and you shouldn't have too many problems. And as usual, if you are struggling or stuck, I'm more than happy to help you out with any of this stuff. And that's all I have for you guys today.